Hi guys, this is Amrit. Next topic today that is electric dipole. So what is electric dipole? By definition we can say it's a combination of two charges, like one charge is positive and one charge is negative. This is plus q charge and this one is minus q charge, and distance between these two we can say it's a two-way. We can write A also, but for calculation purpose, if I take distance between these two charges 2A, that will be better. So one positive charge and one negative charge separated by some distance, this combination is called dipole. This is one term that called dipole. Like if we don't want to name this one dipole, in that case we have to say there is one positive charge, there is one negative charge, and distance between these two charges 2A. So rather than telling this complete sentence, we can simply say this is dipole. So dipole is arrangement of a positive charge and negative charge separated by a small distance. Basically that distance should be very small, then only dipole effect we can get it. So now this is one dipole. Now dipole have a dipole moment. One parameter is there that is called dipole moment, and dipole moment is a vector quantity and it defined as a distance between these two multiplied by one of the charge. Means I'll take either plus charge or minus charge. Obviously I am putting mod value over here and multiply by distance. So this is 2a and it's a vector quantity. So what's the direction of this one, this dipole moment? Direction will be from negative charge to positive charge. Means right now direction of this dipole moment P will be minus q to plus q. So what is dipole? Dipole is a combination of positive and negative charge separated by a small distance. Means this complete arrangement is called dipole, and there is a one parameter to define that dipole moment, that is P, and P is equal to one of the charge, magnitude of one of the charge, and multiply by that distance between that two charges. That distance I am taking 2a for calculation purpose. This distance you can take a, rs, d, rs, r, anything. If I am taking 2a, in that case if I need half distance, that will be a. So if I take a, half distance will be a by 2. So if I take 2a, that calculation will be a bit easier. That's why I am taking that distance 2a. Now what will be unit of this dipole moment? It's a vector quantity, so direction will be there, and what's the direction? Minus charge to plus charge. Now what will be unit of this one? Unit of this dipole moment, that will be, what's the unit of charge? Coulomb. And what's the unit of this distance? Meter. So distance, the unit of this one, Coulomb meter. And obviously we can find out dimension of this one. What's the dimension of this? Dimension of charge, that is what? 80. And dimension of this length, that will be meter. It will be ATM. So dimension of this one will be ATM, and unit this will be cm. So Coulomb into meter. Now based on this one, this dipole moment concept, we'll do one question to clear this concept. Let's say there are three charges. This charge is plus q plus 2q. This charge is q and this one is q. This means minus, plus. And it's an equilateral triangle. Now I need to find out dipole moment of this system. See, so I gave definition, two charges separated by a small distance, that is called dipole. But here not two charges, there are three charges. We can see how many dipoles this structure can make. See, this minus q can make one dipole with this plus q. Now plus q remaining. Now this remaining plus q and this minus q make another dipole. So what will be direction of this dipole moment of this minus q and plus q of this one? Minus to plus, it will be like this. Let's say this is what? P1. And what will be direction of dipole moment due to this minus q of this one and plus q, remaining plus q of that 2q? It will be minus to plus, it will be like this. So that is what? P2. And distance between these two I am taking 2a. So this distance also 2a, this one also 2a. Now what's the angle between P1 and P2? 60 degree. And P1 is equal to P2. So let's say this one is P. So what's the net dipole moment? P dash is equal to under root P1 square plus P2 square plus 2 P1 P2 into cos theta, that is vector addition. So if I put this value, I'll get P square plus P square plus 2P into cos 60, 1 by 2. So I'll get root 3 into P. And what's the value of P? 1 of the charge multiplied by 2A. It means root 3 into Q into 2A. So this is dipole moment for the system. Means it's a vector quantity, and whenever you have to find out combination of 2 dipole, 3 dipole, so we find out each one and after that we add as a vector. Now in NCERT part, if you look at especially NCERT part, in that one there is a derivation of an electric field due to dipole. So I'll do the derivation electric field due to dipole. Now there is a one dipole electric field due to dipole and there is a one dipole over here. This is minus Q charge and this one is plus Q charge. Obviously this is dipole plus Q charge, and at this point I need to find out electric field. Okay, let me at this point I need to find out electric field, and this distance is given, that one is R. This distance is R, means from midpoint of this dipole to this point P, distance is R. Let's say it's a point A. So this distance is R, and this distance is given 2A. And this is one dipole, and this point is on the axis. Point A will be on the axis of this dipole. That's why we say electric field due to dipole, and bracket you can write at axial point. Axial point means on the axis. So electric field due to this dipole at the axis at point A I need to find out. See, once again I repeat, this one is one dipole. Due to this dipole on the axis of this dipole at point A, I need to find out electric field. Now what's the distance of that point A from midpoint of this dipole? That is R, and this distance is very small, means 2A is very less, like very small in comparison to R. If we compare with R, that will be in meter, R will be in meters, that must be in centimeter. It's a very small, we assume that it's a very small. Now this distance will be how much? If I draw this one, this distance will be, see, this one is R, or this one is 2A, so this one will be A, so this distance will be R plus A. See, this is R and this one will be 2A, and this part will be how much? A. So this total will be how much? R plus A. Similarly this distance, this one will be R minus A, because this distance is R and this one is what? A. So R minus A. Now I'll find out electric field due to minus Q charge at point A. So what will be electric field? E1 is equal to KQ divided by R plus A square, and direction, it's a negative charge, so direction will be minus I cap towards this negative charge. What I did, electric field due to this charge at point A, that is E1 KQ divided by R plus A square minus I cap. Now I'll find out electric field due to this charge at point A. Electric field due to this positive charge at point A. So what I'll get, E2 is equal to KQ divided by R plus A square. No, R minus A square, because that distance is R minus A, so R minus A square, and direction will be plus I cap. Now if I want to find out net electric field, see, E1 is electric field due to minus Q charge at point A, and E2 is electric field due to plus Q charge at point A, and if I want to find out net electric field at point A, so I'll add these two. E is equal to vector E1, vector E is equal to vector E1 plus vector E2. So if I add these two, what I'll get, KQ divided by KQ, just KQ I'll take common, and I'll take this one 1 by R minus A square minus 1 by R plus A square. Now if I simplify this one a bit, so I'll get KQ divided by nothing 1, and this one I can write R plus we can write R square minus A square into square, and this will be R plus A minus R minus it will be 2RA. If we solve this one, no, you'll get 2RA. 2, no, you'll get this one 4RA. 4RA. Just like this one, R plus A square, in numerator will be R plus A square, and here R minus A square. If we expand and solve, we'll get 4RA. So after this one, we'll get 2K into 2AQ divided by R square minus A square divided by that is square, not divided by. So we'll get this one. After solving this, 4RA divided by R square minus A square square, I'll get this one. Now R is greater than A. So if R is greater than A, in that case what I'll get, R square minus A square almost equal to R. Almost equal to R square. For example, this one R square minus A square is equal to R square if R is greater than A. Means A is very small in comparison to R. A is very small in comparison to R. It means R square minus A square we can write almost equal to R square. So if I do that thing and I solve this one, so I'll get E is equal to 2K 2QA into R divided by R square and 2 square. So after solving this one, I'll get 2K and 2Q into A, that is called P. So 2KP into R divided by R power 4. So that will be equal to 2KP divided by R cube. And direction will be I cap. So what's your final answer for this one? 2KP divided by R cube. Thank you.